The last thing we're going to look at with the Diels-Alder reaction is going backwards or retrosynthesis. So how do we start with a target and imagine what our Diels-Alder reactants should look like? And I'm going to start this with the same template as if we were moving forward. I'm going to number 1, 2, 3, 4, 5, and 6 because numbers 1 through 4 should be the diene and number 5 and 6 should be the dienophile. And I'm going to imagine just kind of breaking this apart here. And we can actually do a backwards mechanism. So if I start with the pi bond that's already there, I go back there between 1 and 2. This sigma bond's going to go back to 5 and 6. And this one's going to go back to 3 and 4. And so my diene will look like this. And if you want to draw it in the S-cis conformation, that's fine. It's also got a couple methyl groups there. So there's 1, 2, 3, and 4. And 5 and 6 is going to be my dienophile. And the other thing attached to 6 there is this carbonyl. So that's how I'm going to go backwards. Now, what if I have a bicyclic Diels-Alder product? How do I go back to the beginning? I'm going to do the same thing. I'm going to number my cyclohexene carbons 1, 2, 3, 4, 5, and 6. And I'll just call this one 7. And this kind of gives me a big clue that this here is part of a 5-membered ring, or my diene is part of a 5-membered ring. And I'm going to imagine breaking those sigma bonds. So let's do a backwards or a retro Diels-Alder here. So move that pi bond between 1 and 2. This bond will break to go back to 5 and 6. And then this one will go back here between 3 and 4. So my diene will be part of a 5-membered ring. And this will be my dienophile. So here's 1, 2, 3, 4, and 5, and 6, and there is number 7. All right, so you should be able to go backwards as well. If I give you the target of a Diels-Alder reaction, you should be able to imagine what the reactants started out as.